Okay, so let's look at some of these. So when you get to question number 51, do not make 51A complicated. It says the process occurs at constant temperature, expresses change in Gibbs free energy, and change in enthalpy and entropy of the system. 51A, literally, all you have to write is the mother of all thermodynamic equations. Delta G equals delta H minus T delta S. That's all you have to write. Okay? So for 51A, literally, that is it. Okay? That's it. That's the relationship right there. Now, I beg of you, with this test coming up on Friday, I beg of you, there are 4 things on this relationship you have to know without hesitation. 4 different scenarios. When you have a negative delta H and a positive delta S, what's that? How is that going to play out?
That's a hot mess.
That's a spontaneous.
That's a hot mess. Is that always spontaneous?
Of course.
Always.
Every single time.
And here's the and understand why. Just don't memorize it. Okay? If you want to think in terms of Mother Nature likes a hot mess. Okay? Which means it's an exothermic reaction. So what's the sign of delta H for an exothermic reaction? Negative. So I've got a negative delta H minus my temperature, and the temperature has to be in Kelvin. Okay, it cannot be in Celsius, it cannot be in Fahrenheit, it cannot be in squirrels. It has to be in Kelvin. Now, your entropy term, which is the change in the order of the system. In this case, this is going to be a positive delta S, which means the entropy is increasing. Okay? So this is like a fireworks show. You launch the mortar, woo, bright lights, Mother Nature sit back, hitting on the hookah pipe going, it's a good show, okay, right? She is digging this scene, making a mess, it's exothermic, wow, it's cool, okay? If you're a math nerd, it's like, okay, if I don't get the whole Mother Nature analogy, I don't know what a hookah pipe is, here's your mathematical explanation. If a reaction is going to be spontaneous, what has to be the sign of delta G? Negative. So you got to have negative delta G. So mathematically, you're going to have a negative delta H minus a temperature multiplied by a positive delta S.
Always negative.
So you're going to have a negative minus a positive number, so that just makes it more negative. Okay? So one of the things that you'll talk about is in terms of what's driving it towards spontaneity. So if you have a negative delta H, the enthalpy term is driving it towards spontaneity because Mother Nature is a hot mess. If you have a positive delta S, then you can say the entropy term is also driving it towards spontaneity. So you have a negative delta H, you have a positive delta S. Both terms are creating a bigger negative delta G. Okay, that makes sense. Cool, got it, green. So that's scenario number 1. Scenario number 2, you have a positive delta H and a negative delta S.
No.
Never. Ever. Ever. Because here's the reason why. Again, if you go back to Mother Nature. Mother Nature is going to get cold and she's got to clean. Mother Nature is going to have no part of this. Like, maybe I'm cold, I need my sweater, okay? And then you're going to go, Grandma, you can't have your sweater because you're cold, and I want you to clean the house. And Mother Nature's going to go, as I did to Shannon, not going to happen, okay? Not going to do it. Mother Nature will have no part of it, ever, in any scenario. Mathematically, you have a positive delta H minus a temperature times a negative delta S. So you have a positive minus a negative. So what are you going to do? What are you going to do?
Plus.
Yeah, you're going to effectively add these numbers together, which is in no way, shape, or form can you produce a positive or negative delta G, because everything you have a positive minus a negative. So that combination is never going to happen. Okay? negative delta H, negative delta S. Which term is driving it towards spontaneity?
Enthalpy.
The enthalpy term is because that's the hot side. Okay, that's cool. But Mother Nature's going, man, it's a hot, but I got to clean it. Okay? So, when this combination, and this is one of the most important things that you have to do, this thing becomes temperature critical. Because at equilibrium, you can set delta G equal to 0, which is delta H minus T delta S. So if I move this over here, and I get T delta S equals delta H, and I divide that by delta S. So there's two reasons why this can become a critical temperature situation. Number one, you have one term, the delta H, driving it towards spontaneity, and you have the entropy driving it away from spontaneity. So you have two conflicting ideas. Mathematically, when you solve for temperature, and this is the beauty of Kelvin, okay? It's Kelvin, so the temperature always has to be a positive value, okay? So I can't find a critical temperature if these have opposite signs. I can find no critical temperature if I have negative delta H and a positive delta S, or a positive delta H and a negative delta S. I can't find a critical temperature. But I can find a critical temperature if these are either both negative or they're both positive. So when you have that situation where it's critical dependent on a temperature, that means they're either both positive or they're both negative. So if they are both positive, in this situation they're both negative, okay? So you're going to get a temperature. So let's say, I'm just going to make up the numbers. Let's say that's negative 100 kilojoules per mole, and that's negative 20 kilojoules per mole Kelvin. Okay? Pay attention to the units. So, kilojoules per mole divided by kilojoules per mole Kelvin. What units do I get? Kelvin. In this situation, I would get 5. Okay? So if they're both negative, does the temperature have to be below that point or above that point? Big Mike.
If they're both negative.
If they're both negative.
Below.
Oh, beautiful. Why? Mathematically.
Because it's
Call a friend. I'll call a friend. Use goats. I think he said it was horribly non-scientific term.
okay. So because your delta G has to be negative.
Yeah.
If it has to be spontaneous. So you got your negative delta H and your negative delta S.
I did.
So really, so basically, it's negative delta. It's T delta S minus delta H. So your so your temperature has to be low because your delta H has to be bigger than your T delta S.
Ah! See, was that so tough?
Yeah, I mean a little bit.
No. Okay, but Big Mike gave a beautiful explanation. Okay, he did. He gave a beautiful explanation. So this is a fixed value. I can't change that number. Okay, that's a fixed value. The only thing I can manipulate in this whole equation is that temperature. So since I've got a negative, in effect, adding this because I'm subtracting a negative value, I can't let the T delta S term get bigger than my delta H term. So if this gets bigger, then my delta G shifts positive and the reaction becomes non-spontaneous. Okay? So that's why it has to be below a certain temperature. So if you want to remember it this way, negative people bring me down. So if you have two negative values, you have to be below a certain temperature. Now, again, that doesn't mean it has to be cold. That critical temperature might be 1,000 degrees Kelvin. It just has to be below that point. Okay, so get out of your minds that these only occur at cold temperatures. No, it just has to be below a certain point. Okay? Now, positive delta H and a positive delta S. OP, above a certain temperature or below a certain temperature?
Can you say that again?
If I have a positive delta H and a positive delta S, is the critical temperature above a point or below a point? Or does it matter?
Above.
Above. Above.
Chance.
Why?
I don't know.
So your son's gonna feel this one. So then
Yeah, I'll pass it off to somebody else.
So let's go.
Somebody else.
Son, what do you got?
So, for it to be spontaneous, you want Gibb to be negative, of course, but the only way to have this, you have P and entropy be greater than entropy, which means with a high temperature, but with the same entropy, you could beat the entropy change, and that's why you get the negative Gibbs energy.
Beautiful.
So
So,
I did not like
this term here has to be bigger than your delta H term. So that when you subtract it, you generate a negative delta G. So this is why this has to occur at temperatures above. So again, positive people lift you up. So if you've got two positives, wow, that's exciting. Okay? Wow, excited to be around this person. Got to be above a certain temperature. So understand without fail what happens when you have a positive and a negative and a positive, two negatives and two positives. If you're into flashcards, make flashcards. Okay? So let's talk about this. So when you get to question 53, says for a certain chemical reaction, delta H is negative 35.4 and delta S is negative 85.5. So right away, you see two negative values. Which one's driving it towards spontaneity, the enthalpy or the entropy?
enthalpy.
Because that's negative delta H. Okay? So you got the hot side, but this one we've got a hot clean as opposed to a hot mess. Okay? So, is the reaction endothermic or exothermic? You just have to look at your sign of delta H. Does the reaction lead to an increase or decrease in the randomness or disorder of the system? Okay? Look at your delta S term. If your delta S is positive, what happens to the mess? It gets more messy. If you have a negative delta S, you're cleaning. Okay? Now, it says calculate delta G for the reaction at 298 Kelvin. Okay? So when you do that on 53C in kilojoules, you should get an answer around negative 10. Okay? So then it says, is the reaction spontaneous under standard conditions? There you go. Okay? Now, in contrast to that, you have 54. So what's happening on 54? You have a negative delta H and a positive delta S.
Got a hot mess.
You got a hot mess. Mother Nature's going to be digging this. So if you do that calculation to 54C, and you get a positive value, you have done something horribly wrong because of the fact that you know it has to be a spontaneous reaction and you know you have to have a negative delta G. Let me see. There's not a lot of mathematical ones. On 24, it says calculate the value of delta S when 15 grams of cesium solidifies at 28.4. So when you look at 24, let me give you some hints. As soon as you see the word freezes or boils or condenses, that means that it's temperature dependent, which means they're either both positive or they're both negative. So by virtue of the fact that when you see it freezes at 28.4 degrees Celsius, that means it's temperature dependent. Okay? That's it. That you know it either has to be positive, both positive, or both negative. Now think this through. You're talking about this thing freezing, which is code for it's going to solidify. So if it freezes, what's going to happen to the entropy?
Negative delta
It's
S.
going to go down. So what's the sign of your delta S?
Negative delta.
So here's what you can conclude a lot by just seeing the term freeze. You know that it's temperature dependent. It's freezing, so your entropy is going down. So that means you have to have a negative delta S. But because it's temperature dependent, delta H and delta S have to have the same sign. So that means your delta H also has to be a negative value. So just from one word in that sentence, you can figure out the sign of everything. Okay? You can figure out the sign of everything. Now, but because everything is negative, if this is going to freeze, you have to be above or below that temperature. Below. Now, when you get to the question on 24, on B, where it says calculate the value of delta S when you have 15 grams, if nothing else, pay attention to the units. Because of the fact that what are the units for delta S?
Joules per.
Yeah, like joules or kilojoules per mole Kelvin. Just make the units work out. So on 24B, if you are in joules, your answer should be less than 1. Yeah. Okay. Anything else you want me to go over?
Or for 24B, I did not get moles in my answer.
Why do you think they gave you grams?
Well, I just deleted.
That's cool.
Is it okay? Is it like -7 blah 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 to the -4?
Yeah.
Yeah. So it doesn't
If
matter.
you're in kilojoules,
Yeah.
I said if you were in joules.
Right, but we still gotta get moles in there.
My mole's deleted too. I don't know how my mole's
Yeah,
No,
my
your
moles-
your
yeah,
mole's
my moles are
deleted
gone.
too.
I don't know why mole's
Wait, Big Mike, your mole's
Well, you
deleted.
turn it into moles of like the substance and you multiply it by the kilojoules per mole, so the moles cancel out.
Yeah.
Yeah, your moles.
But there's a reason that you have the mass.
Yeah.
You can figure out how many moles that you have.
Yeah, but I don't have moles.
So how do we get it back in the answer?
I don't think it's in the answer.
I don't think you do that.
There has to be.
Okay.
Big Mike. just take it.
So-
Uh-oh.
Getting laughed off the court.
No.
We're getting
So-
taken.
You want to find delta S, right? Okay. So if it's freezing, what's the value of delta G? 0. So you have delta H minus T delta S, right? So to solve for temperature, what are you going to do? Move this over, right? Yeah, so you're going to have temperature is going to equal delta H over your, no. On 24B, you don't want to find temperature. You want to find delta S. So that's going to be delta H over your temperature. But what are the units for delta H? Kilojoules per mole.
The units for delta S are joules per Kelvin.
Well, they don't write that in there, but it's supposed to be joules per mole Kelvin.
So
And here's the reason why.
let's just add moles.
Okay, well, here's the reason why. Because your delta H is kilojoules per mole. That's in joules per mole Kelvin. So then when you multiply it by Kelvin, then you get joules per mole, which what allows you to add it to delta H. That's where it comes from.
Sneaking it in.
No, you really don't sneak it in. I mean, it has to work that way. All right, anything else? Then let's go twice. Done.
You go for 47.
Oh, yeah.
Okay.
I'm just going for more.
So they give you the entropies. So you start with carbon, and that's at 2.43. And then you go down and you end up with 10, which is 51.18. So here's the best analogy I can give you. let's say that I come back next year and they go, Burkamp, you know, you're for 30 years, you've just been a hot mess inside that room, and you're just too messy. So we're going to put you into like a small little cubicle room to teach in. Okay? So where can I create more of a mess? In this room or the tiny cubicle? This room, because I have a lot more microstates, right? I got stuff that I can hang on the walls, I got cabinets, I got drawers. So look at carbon. How many, let's start with this. How many valence electrons does carbon have? 4. As you go down, what happens to the size of the Chihuahua cloud? Bigger. You have more and more Chihuahuas. So what happens to the potential entropy?
Increases.
It increases because you have more stuff that can get jacked up. That's why. The more stuff you have, the more jacked up it can get. Okay, anything else going on? Twice, delta H, delta S, so